just take a look around you, wherever you are right now. I'm willing to bet you can spot at least a dozen things made of plastic. From the bottle on your desk to probably the chair you're sitting on. These materials are absolutely everywhere. But how much do we really truly know about them? Today, we're going to dive into the secret molecular life of plastics to figure out what makes them so incredibly versatile. It sounds like the start of a weird riddle, doesn't it? You've got a rigid bottle, a vest that can literally save a life, and a toy for kids. I mean, on the surface, they couldn't be more different. But here's the thing. They all share this fundamental secret, a common chemical identity that gives them their own unique powers. And trust me, by the end of this, you'll know exactly what it is. All right, so to crack this code, we have to start small, like really small, molecular level small. Our first secret, the key to everything about plastics, is all wrapped up in a single word: polymer. This is the blueprint for everything we're about to explore. I want you to really think about the scale here. We all know about simple molecules, right? Like water, H2O, which has just 3 little atoms. A polymer molecule, by comparison, is a giant. It's this massive chain made of hundreds, thousands, sometimes even millions of atoms all linked up. By the way, nature is the original polymer master. Your own DNA is a polymer. But in the world of plastics, this incredible size is the #1 reason they act so differently from other materials. So if a polymer is the long chain, what are the individual links? Well, they're called monomers. You can just think of them as single paper clips or maybe beads on a string. They're the small, identical, repeating bits that, when you join them all together, create that massive polymer chain. Okay, here's a great way to picture it. Imagine a gym just full of individual boys. Those are our monomers. Now, when someone gives a signal, they all join hands, and suddenly you don't have a crowd of individuals anymore, right? You have one long connected chain. That whole process of linking up, that's called polymerization, and it's basically how every single plastic is born. All right, so that brings up a pretty big question, doesn't it? If all plastics are just these long chains of monomers, why aren't they all the same? Well, that leads us right to our second secret. Not all polymer chains are created equal. The way they behave and interact gives each plastic its own unique personality. I mean, think about it. They're both plastics, but their properties are completely different. One is stiff and strong, it's designed to hold pressure. The other is super soft and stretchy. The answer to this mystery is all about how their polymer chains respond to things like heat and water. So the first big personality split is how they deal with heat. Over on the left, we've got thermoplastics. Think about them like ice. You can melt ice into water and then you can freeze it again. These plastics are just like that. They soften when you heat them and you can remold them over and over. This is huge for recycling. Then on the right, you have thermosets. These guys are more like an egg. Once you cook it, you can't turn it back into a liquid, right? When you heat a thermoset, it just scorches and burns. And this difference is incredibly important. A whopping 85% of the plastics that we use today are thermoplastics. Their ability to be melted down and reshaped is the entire foundation of our modern recycling systems. All right, the next personality trait is all about a polymer's relationship with water. Some are hydrophilic, which literally means water-loving. They attract water, they absorb it. And then you've got the opposite, hydrophobic, or water-fearing. These guys repel water, which is what makes them waterproof. Let's see how this plays out in stuff we use every day. And you see this in action all the time. That super absorbent polymer inside a diaper, totally hydrophilic. It loves water so much it can soak up many, many times its own weight in liquid. On the flip side, a polystyrene cup is hydrophobic. Its water-fearing nature is exactly what you want to keep your coffee from leaking all over your desk. See? Different personalities for different jobs. Okay, so we've got thermoplastics and thermosets, we've got water lovers and water fearers. With all these different personalities, the huge rise of plastics created, you guessed it, a huge problem: pollution. So to solve it, we needed a way to tell them all apart. We basically needed a decoder ring. And this, right here, became absolutely critical. If you just try to melt down a soda bottle and a milk jug together, you just get a useless lumpy mess. Effective recycling depends entirely on sorting plastics into their correct families first, which led to a pretty brilliant solution. I know you've seen these, the little numbers inside the chasing arrows on countless products. This code is the decoder ring, telling us the polymer family. So number 1, PET. That's for things like soda bottles. Number 2, HDPE. That's for those sturdy milk jugs. And number 6, PS, that's polystyrene, like in those cups we were just talking about. This simple system is the backbone of pretty much all global plastic recycling efforts. So, we've unraveled the polymer chain, we've explored all their different personalities, and we've even cracked the recycling code. What does this all mean for us, for our future? Ultimately, it all comes down to this. Understanding the simple science of monomers and polymers is what allows us to design materials that can do absolutely incredible things. From keeping our food fresh to stopping a bullet. It gives us the knowledge not just to create brand new materials, but also to manage the ones we already have way more responsibly. I want to leave you with this thought from Charles Goodyear. Back in 1839, he accidentally dropped a mix of rubber and sulfur on a hot stove. Now, to anyone else, it would have just been a stinky mess. But Goodyear, who had been obsessed with making rubber better, he saw something amazing. A new, stable, waterproof material. He understood what he was seeing. This accident gave us vulcanized rubber, and it completely changed the world. And that, I think, is the real secret of plastics. The power isn't just in the material itself, but in our understanding of it. The next world-changing discovery might just be waiting for a mind that's prepared to see it.